All right, this is our last video for section 6.1. So this is video number 3, and we're going to talk about compound interest. So this is interest that's compounded more than just one time per year at the end of the year. So this is our formula for compound interest, and this is definitely something you want to write down. This formula is very important. Put it on your note card or whatever. And the compound interest formula is A of t. So that's your amount at time t. It's equal to your principal, the initial amount you started with, 1 plus r over n. R is your annual interest rate in decimal form, and n is the number of times it compounds per year, and t is the number of years. So 1 plus r over n to the nt. So when they talk about the number n, the number of compoundings, if they're talking that it compounds annually, that means it compounds one time per year. If it compounds semi-annually, that means it's 2, quarterly is 4, monthly is 12, weekly 52, daily 365, and hourly 807.66. Most of the ones I don't usually use hourly. Most of the ones are one of these guys, and you should know those numbers for those compoundings. Let's do an example of this problem. Right, so we'll practice using the formula. You're going to deposit $1,000 into a saving account that earns an annual rate of 1% interest. It is calculated and compounded monthly. Find the amount in the account after 10 years. So let's plug it into our formula. A of t equals, I'm going to zoom out just a little more so we can see the whole formula. Well, the first part is P, and that's the amount we start with. So in this case, it's $1,000. 1 plus, we need to figure out our interest rate. Well, they're telling us our annual interest rate is 1%. So we put that as 0.01. And how often is this compounded? Well, it's compounded monthly. Monthly means 12 times a year. So I'm going to put a 12 in there to the 12t. So there is my generic formula that I'm going to use to solve this problem. You can simplify it down a little bit if you want to, or you can just leave it like that. We need to find the amount in the account after 10 years. So we're using our model and plugging in 10. A of 10 equals 1,000. 1 plus 0.01 over 12 to the 12 times 10. So the first place we need to work is inside the parentheses using our order of operations. And inside the parentheses, we need to do this division sign first. So we're going to take 0.01 and we're going to divide it by 12. And you get a really small number. It's 0.000833333. Leave that alone in your calculator. Use your calculator rounding. We're going to add 1 to that. And then we're going to raise that. So right now I'm at A of 10 equals 1,000. 1.0008, lots of threes, as many as you can keep in your calculator, to the, and now I'm going to raise this. We need to do this multiplication in the exponent. 12 times 10 is 120. So now when we look at our order of operations, we need to do the exponent first and then multiply by 1,000. So I'm just going to leave that number in my calculator, raise x to the y to 120, and then I got 1.10512. I'm multiplying that by 1,000. And now for my final answer, I got 1105.124, so 0.12 when I round to the nearest penny. $1,105.12. All right, so if we can compound annually, semi-annually, quarterly, they have something called continuous compounding. So that means compounding all the time, and this uses a new number for you, E. E is an irrational number. It's kind of like pi, and it's about equal to 2.72, and your calculators will have an e to the x button in them. So look at your calculator, and it will have a button that says like e to the x, and that's how you raise the exponent on x. So if we're talking about a bank account that is continuously compounded, we have a slightly different formula. It's very similar, except for that it's A of t equals your initial principal times E, which is a special number, right, in your calculator, 2.72-ish, to the RT. So let's go ahead and do an example of continuously compounded. So we're going to do $1,000 again. That's our principal. We fill that in for T. E always is just going to be E to the, what's our interest rate? 1% again, 0.01 T. So this one's even a little bit simpler to use. So there's our model. And now we're going to see how much is in the account after 10 years. So A of 10 equals 1,000 e to the 0.01 times 10. The first thing you need to compute is 0.01 times 10. 0.01 times 10, which hopefully you can do in your head, is 0.1. So that's what you're going to do. You're going to raise e to that power, which gives you 1.1051 in your calculator. Multiply that by 1,000 and raised round to the nearest penny, and you get $1,105.17. Now, before we even look back, do we expect this to be more or less than our compounded monthly? Well, we expect this to be more than compounded monthly because the more often you compound interest, the more interest you're going to get. Because each time you compound it, your amount in your account gets a little bit higher. So the next time you compound it, you're getting interest on a bigger amount. So let's compare this to what we got last time. This was $1,105, same. We got 17 cents instead of 12 cents, which doesn't sound that much, but an interest rate of 1% isn't very good. All right, that's it for section 6.1.